everyone. Today we are going to start a design a dipole antenna using CST Studio Suite. And first we have to open a new project, and in we select a microwave and RF optical. Since we use an antenna, it comes under this category. And from the available templates, we choose antennas and wire. Then select the time domain. In the time domain, we have to set the dimensions to millimeter and frequency is gigahertz. It's already in there. Give next and name it as okay. Before name, we have to give the frequency minimum, that is 0, and frequency maximum is 2. Click on E field, H field, and far field. I'm just giving define at 1 only. Give next and give the name as dipole antenna. Click finish. So this is our model look like, and this is our center point. So so designing our dipole, we have to give a modeling a cylinder. This is the center point of our working plane, and we have to just double click and scroll. Again double click, and once again. So this is inner radius in working plane. If you double click again, you give the double click means we have properties. That's just give the name as dipole, and orientation is z, radius is r, and inner radius is 0, x center and y center is equal to 0, z minimum is minus l by 2, and z maximum is l by 2. Segments is 0 and component is 1. And material is PEC, just PEC. If you give the preview point, we can able to give the values for R. So we gave the value for R is equal to 2.5 mm, and for L is 150 mm. So this is our diagram is sorry. This is our dipole look likes. And again click material, load from material library. So you have to choose copper analyte. So copper analyte, and then give load. Now click OK. So this is our dipole looks like after giving the uh, components. You can see the see in our component point, component 1 and dipole. Then we load the material as we gave again inside a cylinder structure and name it as gap. So again modeling and cylinder. Same, give a gap, name as gap, and orientation is z. Outer radius is r, and inner radius is 0. X center is 0, y center is 0, Z minimum is minus gap divided by 2, and Z maximum is gap divided by 2, and segments is 0. Component is component 1, material is copper analyte. Preview, if you click the preview point, we can able to give the value for a gap, that is 20 mm. Oh, then click OK. So you have clearly see the point. We have to cut these points. Okay, now we have to cut this gap point. For that, okay, after creating these 2 points, these two structures, we have to subtract the gap from the dipole using a boolean subtraction option. So just click dipole and boolean subtract gap, enter. So now you can able to delete that one, or finally subtracted that gap in between the dipole. So now we pick um, now we pick 2 points, 2 points at the center of gap for extraction. In the simulation, we click gap. Sorry, before going to simulation, I'm just adding a modeling gap. Big point is C, that is in x-axis. If we want to rotate the diagram or the design, just click control and rotate, or else you can using this symbol, you can able to rotate again. Pick point, pick circle center P. So now you can see the point P2 and P1. Okay, after giving the 2 points, now we are going to simulation and just clicking the frequency range, that is 0 and 2. We already gave that in initial stage. Just click OK, and for discrete edge, just click discrete port. So now you can see the port between the 2 points. So now we have to select S parameter as it is and the name as 1. No need to change any other things, folder and label. And impedance is Z0, Z0, not O, and radius is 0.0 only. Untick the use peak and just apply. You can able to give the value for Z0. Give 50 ohm, then click OK. So and finally we can add the field monitors. Just click field monitor. One second. Before selecting the field monitor, I'm just in zoom, unzoomed it. E field, okay. Yes. And click field monitor and H field, okay. And far field, okay. So these are the fields we just gave the E field, H field, and far field. Now selecting setup solver. For time domain solver, mesh type is hexahedral and accuracy is minus 40. All ports only. Just give apply and start. So our design is calculating the matrix and finally processing. So successfully finished secondary quantity evaluation. Okay. So now you can see the difference. In E field, this is our output in E field. So you can rotate, and this is our H field. So this is our surface field. You can change the arrows and contour. So this is our S parameter and port signals. And Z matrix, Y matrix. So this is our far field. In 3D. Thank you.